Topics covered in inverse trigonometric functions. Welcome to our lesson on inverse trigonometric functions. In this section, we will first explore the conceptual foundation of inverse functions. You will learn why it is necessary to restrict the domains of trigonometric functions to make them bijective, meaning they are one-to-one and onto, which is a requirement for an inverse to exist. Next, we will define and identify the principal value branches for functions such as sine inverse of x, cosine inverse of x, and tangent inverse of x. We will also conduct a detailed analysis of the domains and ranges of these functions to understand their behavior. Finally, we will study various properties and identities that are essential for simplifying complex trigonometric expressions and equations. Establishing this theoretical groundwork is crucial, as it will allow us to understand how these functions are applied to solve practical, real-world problems, which we will discuss in the following slide. Real-world applications of inverse trigonometric functions. Now that we have established the theoretical foundation and the properties of inverse trigonometric functions, let us explore how these concepts are applied in the real world. In the fields of engineering and architecture, these functions are essential for calculating the precise angles of structural components, as well as determining slopes and inclinations. Similarly, in physics, they are used to find the angle of refraction in optics and to analyze the trajectory of projectiles. Beyond that, inverse trigonometric functions are fundamental to navigation and aviation, where they power GPS technology and triangulation to determine exact coordinates and headings. Finally, their utility extends from computer graphics, where they help in rotating objects in three-dimensional space, to astronomy, where they are used to measure the distances between celestial bodies. Essentially, these functions are indispensable tools for solving complex spatial problems in the physical world.